We talked about the four major different types of air masses, right? Maritime polar, maritime tropical, continental polar, continental tropical. But the boundary between two different air masses, where two different air masses meet up against one another, that's called a front. Now, there are four types of fronts, and this goes to the lab that you did yesterday. In the lab, you only looked at two types of fronts, but there's actually four. So you have a warm front and cold front. Those are the two fronts that you looked at yesterday. And then there are an occluded front and a stationary front. Okay? So, a warm front, when a warm front comes through, that means that the temperatures that it's bringing with it are warmer. I didn't necessarily mean hot. Let me give you an example. If it's 25 degrees outside, right? Warm front comes through. After the warm front comes through, it's now 30 degrees. Is 30 degrees warm? No. But isn't it warmer than the 20-something degrees that was in place? Yes. So that's the result of a warm front. Same thing during the summertime. Cold fronts. Cold fronts are what's responsible for your thunderstorms, all right? So warm fronts, when you have a warm front coming through, the precipitation is going to be over a longer period of time, but it's going to be lighter, all right? Light rain. Whereas a cold front, it's going to be very, very heavy precipitation, but over a short period of time, half hour to an hour, not very long, okay? So during the summertime, when we get a cold front, let's say it's 95 degrees, cold front comes through, it's now 91 degrees. Is 91 degrees cold? No, but isn't it cooler than the 95? Okay, so basically it's just describing which direction the temperature is going. If the front comes through, the temperature is going to be lower. After it comes through, it's a cold front. Reverse for the warm front. So open up your notes, please, and copy down.
Like this weekend, they call them for up to 48 degrees on Saturday.
Uh,
Today, that's 25 degrees. We're warm.
So with a warm front, now remember when we talked about humidity last week, right? Yes? Maybe so? Okay. Humidity is the amount of moisture in the air, right? So warmer temperatures can hold more moisture than colder temperatures can, okay? So what happens to the temperature as we travel up through the troposphere? What happens to the temperature as you get to the top of a mountain? Gets colder, right? So remember that warmer air holds more moisture. When warmer air rises in the troposphere where the temperatures get colder, guess what? That air, because now its temperature is dropping, can't hold that moisture anymore. So that's what leads to cloud formation, is the condensation of that water vapor, all right? So with a warm front, the clouds aren't going to be as tall. That's why it's a light precipitation. But with a cold front, the clouds are much taller. This is what leads to your thunderstorms, all right? Taller, heavier precipitation. Is everybody done with this slide? Okay. Now with a cold front, the cold front forces the warm air up much quicker. That's what leads to those tall clouds.
Is called a front, and it's along these fronts that most of our sudden weather changes occur. There are four different kinds of fronts: cold, warm, stationary, and occluded. When a cold air mass advances on a warm one, the result is a cold front.
The cold air is dense and heavy, and so it rushes quickly underneath the warm light air, producing strong winds.
The warm air is suddenly forced upwards, and clouds form very quickly. The rain produced by a cold front tends to be short, but very heavy.
On the other hand, when a warm air mass advances on a cold one, the result is a warm front, which advances only about half as fast as a cold front and produces milder breezes.
In a warm front, the warm air rises slowly upward over the cold air. The warm air cools gradually, producing wispy cirrus clouds and then layered stratus clouds. The rain that comes with the warm front tends to be light and steady and may last for days.
You know, now that I think about it, the storm has spoiled our blade and came up awful quickly.
Yeah, and look how hard it's raining now. Maybe it's a cold front and it'll stop soon.
When a warm front and a cold front meet, but the air masses stop moving and neither advances on the other, that's called a stationary front. These are like warm fronts in slow motion, with very mild breezes and very light rain that can last for days. Lastly, when a warm air mass is caught between two cold air masses, that's an occluded front. Occluded fronts produce a mix of both cold and warm frontal weather, followed by more cold frontal weather.
Well, I hope we don't have one of those. It might rain buckets for days.
All right, so again, cold front, again, it's going to lead to your clouds that are taller, which means heavier precipitation. You can see it's heavier precipitation, but it's over a shorter distance. Whereas with the warm front, if you look, the clouds aren't as high. The precipitation is lighter in nature, but it goes over a longer distance. And this is the last one. Just want to make sure. No, we got two more slides of this. All right, so climate, again, as Christian pointed it out earlier, when we're concerned with climate, we're talking about the yearly conditions. All right, so we live in a mild climate. All right, mild climate. We have 4 seasons. Our winters aren't overly hot, or overly cold, and our summers aren't overly hot. Now, these areas that are in red, these are tropical climates. In other words, it's warm all year long. The amount of sunlight they get each day is the same throughout the entire year, and they get precipitation throughout the year also. These climates above tropical and below tropical, this color here, orange, these are your deserts. Low precipitation, very dry conditions. And then as you get more north and more south, you get into your continental climates and then your polar climates. Now, does anybody see the relationship or see any pattern here in the map with respect to where the reds are, where the oranges are, where the greens are? What's the pattern? Yeah, it's all along the same lines of latitude. Now, the last thing I want to talk about is forecasting weather. Why are weather forecasts today better than they were 50, 60, 70 years ago? Why are they better today? What has changed in the last 100 years?
They have better technology.
Better technology, such as what? Think about something that we put up into the exosphere. Satellites. Supercomputers. All right? These are the things that have helped them make better predictions with respect to the weather. So again, the individuals that are responsible for studying and predicting weather are called meteorologists. So when you look at a news forecast and they're giving you the weather, that's not just a TV personality. That's somebody who's actually been to school to become a meteorologist. So I just want to show you a 4-minute video on fronts. Oh, commercials. Oh no.
There is a weather front's just gradually.
Hold on a minute. Let me see if I can fix this sound a little bit.
Warm front bringing milder air across the south.
All right, now. All right, now what I want you to do is go to Google Classroom and work on that weather fronts worksheet that was for homework. Oh, and Arlene, you can work on the lab.